right? Everything's going to be in a video. So I'm going to come up here. Now I've got my one IMA surface that's visible. Yours may be different. You may have the second visible and this first one invisible. It just depends on the order, the one you pick first for the merge. So if these are backwards, don't worry about it. It was just I picked the bottom surface first and then I merged it with the top surface. That's why the bottom is showing first. So that's the only difference there. So I want to create, I've already got this out there for you. I'm going to make this surface the defined working location. And so I'm going to turn this into to a GSD surface by using the join tool. And now that's a GSD surface. I noticed it hid that first one. I'm going to unhide that because I do not like, I want to make sure I know which one I was working with. And then I'm just going to hide the geometric set. That's just a wisdom point for you. And then let's do a symmetry on this. So I can take this surface, which is a GSD surface now, and I can use the Symmetry Tool, which is not here in the, I keep forgetting, the Symmetry Tool is not one of these available tools. You can go to the GSD workbench if you want to, or you can type in C:"Symmetry and do it that way. I'm getting to where I do that more and more. And I can look at these, I can look at your models and really tell if you've got, even at this stage of the game, I can eyeball. I've seen so many of these, not just this, but so many surface models that do not meet those two principles of symmetry I talked about. But if you want to really double check, I'm not sure this is on your, there's this isoforms mapping analysis. It's either in here. I don't remember if I customize and put that in here or not, but well, tell you what, let me join these together first. Pre-select the two, use the join tool. Now it's one surface. But I can use this wrong tool. I can use this isoforms, select this surface. It gives me what I call a porcupine analysis. And I can look here and see that's a reflection. I can look at that reflection here and see the smoothness as these reflections cross over. And I'm going to goof this up intentionally and just to show you, hopefully I can get out of it, what happens. It's not going to be dramatic, but let's just say I threw this off just a little bit. Tell you what, before I do that, save. So I'm going back to the original GSD surface, actually the merged GSD surface. Let's throw one of these off. All right, see what happens to my porcupine analysis? Now that I just threw that one little bit off. Then let's see if I can get it back. And that's it back. So it makes a difference. And that's an easy way to check your stuff. And that's the way I grade a lot of stuff. If I have the time, I'll throw a porcupine analysis on it. I've even had requirements with students in 458 where they have to submit the porcupine analysis as part of their submission. You're welcome to do that too. Can adjust how it looks. The big one is how well it crosses over that seam. So that's a porcupine. I call it porcupine. That's a zebra stripe analysis. You can do a porcupine analysis on this too. I can grab this porcupine analysis. I can go over this seam, holding down Control key. Oh, that does everything. You can see the seams. And that there is G1 continuity. going across there. Better continuity here and here. They'd have to require additional manipulation to make it G2 continuity, but that's G1, which is fine. It's not the best reflection in the world, but that's okay. So that's a porcupine across the seams. And you can hide these analyses too if you need to. Okay, so that's the surface. Now we need to turn it into a solid. So I'm going to go to my part body, make it my defined working location. You've got to have, you can only solidify one surface, but I've already got them joined, so we're good there. Go to part design, go to insert surface-based features, and let's, all right, oh, here's another one. Okay, so this is something I was practicing with the other day. So if I did a thick surface, so I'm going to solidify that, and let's go, and notice it's solidifying toward the inside. So I solidify that, so, which is fine. Um, but when I solidify that, it solidifies all these edges and it's solidified normal to the surface. And so if you're looking at this from the side, you can get some unusual, I mean, it did what it did, but it may not be what you're looking for as far as how it extrudes because it is going normal to the face. So sometimes that may not be what you're looking for. And oftentimes in surface modeling, that's not what you're looking for. It may do for class, but that may not be what you're looking for as far as your final design. So here's another thing you can do. I'll leave this up optional for you. But if you go back to this, you can fill in this open bottom. I'll just show you how to do it. Now I'll leave it optional for you. It depends on, but I'll go back to GSD Workbench or go to GSD Workbench. I'm not sure if this may be in the IMA Workbench too, but I'm going to use this fill tool. It's on the surfaces toolbar. I'm going to do a fill, and I'm going to right click in here, and I'm going to go create boundary. This is just the way I like to do it, and I'm going to select this edge, and it's going to go around and select the entire boundary. You can do that in the tool, or you can do it as a separate feature if you wanted to. But there's a close, so I just close that. And then I can join these two together. Okay, so now that's all one surface. And then when I come back and I do my part body, go back to the part design workbench. If I do a solidify now from the part design workbench, I would do a closed surface. That's a closed surface. Let me hide here. So that's a closed surface. And then to get the opening on the inside, do a shell. I think I did 3 mm before. And then that gives you, I think, a lot cleaner lines across here. So notice how this is running more horizontal there compared to, I'll put another body in here, compared to what would happen if I did a solidify, a thick solidify on this before I did the fill. 3 mm. It's kind of hard to see. A little bit more, you can kind of see this little background, this little edge right in here. But if I hid that body I just created, see how it goes away? This is more horizontal here. Whereas if I show this again, see how it kind of moves down. So I think this second method, this first method with the shell is a lot cleaner model. And that's my personal opinion, but I'm going to leave it up to you which one you do. But to me, I find that to be a lot better. But of course, now, if you're at this stage, you know me, I don't like G0 corners, right? So here I would take, and let's do a tri-tangent. Where am I working here? Part body. I'd do a tri-tangent here. You may recall this from 226. And I just rounded that entire edge. And all of this, and that's a solid model. So all of this ties back to that IMA model that we created. So if I make any changes to the IMA model, it's going to update everything you see here. But you can still see the seams. See how these seams are connected? Those are the same seams from my IMA model. So it was important that I spent a lot of time getting these seams lined up. So I've got these good transitions. And I can see it in student work when I see these little coupling seams here and they're all, jumping. You got all kind of stuff going everywhere. So if I see these seam lines just kind of going everywhere and waving and just weaving their way or across the model, and they're not smooth, I know you got poor surface modeling. If you show this to me like this, that's an A. This is an A, by the way. I didn't mean to do an A. I meant to do a C. I would give myself an A on this one right now because I took the extra time to get it all lined up and stuff. But it ended up being an A. I could have spent more and more time working on an A plus, but it just ended up being an A, probably because I practiced so much and I knew exactly what I was doing. You'll fumble and accidentally move control vertices off of alignment and all kind of stuff. Be cursing and stomping the floor. So just warning, because those are all things kicking the dog and throwing the cat out the window, that type of stuff. So just because you forgot to move a vertex the right way. And I would never throw the cat in the street. I just threw him out the window. So any questions about this? But again, obviously, it still goes back. Watch what happens if I go, hey, I need a comfort seat. So I can still come in here and go, okay, I'm just going to grab all of these, right? Let's just tug this out just a little bit. Punch out of it. See how the whole seat moved out? Because my design was good. And that's, again, it goes back to design. That's design work. You get your model set up. If you need to do some tweaking, just make sure you know what you're tweaking. And you know what's going to happen when you tweak. So I could still move some stuff around eventually and probably end up with a regen error if I've got some surfaces that kind of just start overlapping. But, I've got a fairly robust model sitting here. Hey, questions? Woo!